Hey guys, welcome back to 2 Minute Coder. Today we're doing Leetcode problem 33, which is search in rotated sorted array. So just take a moment to pause the video and read the question. Alright, so we can instantly see here that we must write an algorithm with log n runtime complexity. This means that we have to do a binary search on this nums array, right? And luckily, it's given to us that nums is sorted in ascending order with distinct values, but the problem arises when we find out that the integer array is rotated k number of times, where k can be anywhere from 1 to the length of nums. Alright, so what that means is, in a way, it's getting unsorted, okay? Because in a normal binary search, we would first compare our target to the midpoint and then either go left or right. But holistically, that's what we're going to be doing, but it's going to be a little bit more complicated than that. So let's get the basis of our binary search written. So we need 3 pointers, left, right, and our midpoint. Right, so left is 0, right is going to be nums.length minus 1, and then while left is less than or equal to r, we're going to find our midpoint. Right, so L plus R divided by 2. So here, one of 3 things can happen. First thing is we find our target. So if nums mid is equal to target, then return mid, because we have to return the index. Second thing that's going to happen, or that could happen, is we find that we are in the left sorted array. And the third thing that can happen is we find that we are in the right sorted array. So what does this mean? Let me just bring this up. Okay, if you look at this nums array, right, its values from 0, 1, 2, 4, 5, 6, 7. Okay, it's in ascending order. But now that it's been rotated and 0 is in the 5th index, or 0, 1, 2, 3, 4th index, it's technically we can't do a normal binary search on it, right? Because say we have to find 0, our target is 0. If we compare our midpoint, which is 7, with 0, normally in a normal binary search, we would think that 0 is to the left of 7, right? But that's not the case, because when you rotate the array, this is what happens. You have one side which is below this line, that is going to be the minimum value up to a certain point, and then you're going to have a side or a subarray to its left, which is going to start from the max of the right subarray and keep on ascending. Okay, so we need to know if we are in the left subarray or the right subarray, right? Because you can see here 4, 5, 6, 7 is a sorted array on the left, and 0, 1, 2 is a sorted array on the right, hence the names. Okay, you can see that here as well, 4, 5, 6, 7, 0, 1, 2. All right, so how do we know if we're in the left sorted array? So we know that if our left pointer is less than or equal to our midpoint, we are in the left sorted array. Now that we're here, do we search right or search left? All right, that's the question. So in what case do we search the right? We search the right if target is greater than our midpoint, or target is less than our left pointer. Okay, let's just put that in an if statement. So if target is greater than nums mid, or target is less than nums at left, we will search right. So we will increment or move our left pointer up to mid plus 1. And then in the case that we have to search left, we'll do r equals mid minus 1. Right, so case of searching right, case of searching left. So why does this happen? Say we are at 7, right? Our midpoint is 7, and our target is 0. We know just by looking at it, we have to search the right subarray. But why is that? Because we know that it's not although 0 is less than 7, we know it's going to be to the right of 7 because it is also less than our left pointer, right? But for example, if our target was 5, right? Target is neither greater than our midpoint, and it is also not less than our left pointer. So we know that it's a case of searching left, right? Say that our midpoint is 5 and our target is 7, okay? Our target is greater than our midpoint. So here, this first one, condition is true, so we search right. Okay, what if our target is 2 when our midpoint is 5? Although 2 is not greater than 5, 2 is less than our left pointer, so we know that we have to search right. Okay, so those are all the cases for when we are in the left sorted array. However, if we are in the right sorted array, logic stays the same, but it's kind of flipped. Okay, so if target is less than our nums at mid, or target is greater than nums at r, we will search left, right? So we'll move our right pointer, else we will search the left. So we'll move our, sorry, then we'll search right, then we'll move our left pointer, right? Right plus 1. Just keep in mind, if we want to search left, then we move our right pointer, and if we want to search right, then we move our left pointer. Okay, so this is the right sorted array, right? And if we don't find our target in this while loop, then we know to return -1. Right, so let me just go over this right sorted array. So we know from this check if we're in the left sorted array. If we're not, then we know that we're in the right, because, for example, our midpoint is 0, or sorry, our midpoint is 1. 1 is not greater than our left pointer, so we know that we have to be in the right sorted array, okay, the one on the right. Now that we know we're there, how do we know where to move? So again, as I said, our midpoint is 1 and our target is 0. So our target is less than mid, so we search left, right? This is search left, this is search right. Okay, what if let's find a case for this. Target greater than nums at r. Okay, so say that our target is 5 and our midpoint is 1. Okay, 5 is greater than 1, so our target is not less than our midpoint, but our target is greater than our right pointer, which means that it's going to be in the left subarray. Okay, and if none of these are evaluated as true, then we know to search right. Okay, so let me just run this. Right, great, accepted. Now let's submit. Oh, what? Something has gone wrong. Oh. Instead of 1, I put L. Let's submit that again. Alright, so that was Leetcode problem 33. Hope you guys enjoyed, and subscribe for more.